So welcome to the Node.js Node API team meeting for January 28th. Just because not everybody shows on the screen, I'll just mention that today we have with us myself, Nicola, Chenzong, Gabriel, Kevin, and Vladimir. So before we get started, does anybody have any announcements they'd like to share?
Nothing here.
Okay, I'm going to share our milestone 11 and we can go through our regular agenda here. So the first one is to take a quick look at our stale issues. So let's go down to the bottom. This one, I don't think there's anything new on this one. So I hear from anybody, I'll assume that, but we'll leave it on the list. This one, I think, Vladimir, you did add some more comments on one of the related discussions or PRs, right? Yeah, on this one. And it seems pretty clear to me that sort of answers the question we were thinking about, worried about. Does anybody have any more questions or thoughts on that? Like, I think this would lead us to say we're comfortable marking all methods const, which don't modify, internal state. And I guess I wonder a little bit, why can't the compiler figure that out itself? Like, because I assume if we mark a method const and then it tries to modify some internal state, it'll tell us, right?
Yeah, it must be compilation error in this case.
Right. So it's okay. So if we mark something const and it's not const, it should give us an error. So it should be safe from that perspective. Does adding const, like, is there any way that breaks existing code?
No, it's because adding const is just adds restrictions, additional restrictions. So technically it doesn't loosen anything.
I just checked the PR and it doesn't change any of the tests. So presumably the tests and their usage of the API continues to compile with this change. And that's actually a good exercise. You must not change the tests and they should still work, because if the tests work, chances are Folks's code will also work still unmodified if we add const. It will probably also help performance slightly, because the compiler is probably able to optimize things knowing that there will be no accesses. So I think it's a benefit overall.
Right. Since it can enforce the const, I'm just sort of wondering aloud, like, since it can actually enforce the const, like it gives us an error if it's not const, and we do something that's not const. I guess what we're saying when we mark it const. Okay, so here's the downside of marking const. It's like, what we're saying when we mark it const is we will never make it non-const, because that would, like, to go from const to non-const is a breaking change. I was just trying to understand, like, why doesn't the compiler just enforce it automatically? But that's probably the reason, is like, you're basically making a commitment, you'll never go back on that.
Actually, I mean, in terms of like ABI stability, I don't know that it is a breaking change, because removing const means that our internal implementation may now modify the state, right?
But it means that code that, like, what people are asking to add const so that they can call it, like, say, from those lambdas and stuff, which they can't do today. And so if we add the const and then later say, oh, but we need to actually have our implementation do something which is non-const, and we remove the const, we will break that code.
Yes. I don't know. Will we though? Like, so.
Well, if you had a Lambda that was using it that couldn't use it without the const, and we remove it later, that code's broken. Like,
But I mean, non-const is more permissive than const, right? So the analog I'm thinking about is we had this in core in thread safe function at some point where we made like a change like this and it didn't break the code. I just
no, but
kind of
it's like
remember.
it's not more like non-const is not actually more permissive. It's more permissive for our code. It's less permissive for the callers.
Okay, okay. I think that's the key here. Does adding const to the function change like the mangled name of the function, right? And actually that doesn't even matter, right? Because the user's code is never dynamically linked against these functions. It's always statically linked, right?
No, it's that when they recompile their code, it will no longer compile.
Why not? All they do is call the method. They don't, they
compiler,
don't.
Like the whole reason that people want it to be const is because, like, say from the Lambda, it will not let you call it unless it's const. Right. And so if we add the const, it will let it be called in more places, which is the benefit. But if we later want to remove the const, we can't do that because that will now actually break people's code. We would have to like come up with a new version of the method that's non-const or something like that.
Yeah. Okay. All right. Yeah. I don't quite follow, but I can accept that. And well, I mean, what is to prevent us later from doing that? Like that's okay.
I think it is worthwhile to think about the opposite way of having const and then removing it, or rather like putting it there and expecting things to work. Just for example, we do have that open issue of the async progress worker having const signal, and that's causing some compilation errors on that. So we have to go through the process of removing it. And I think there's an open PR for that. But I think that if we add it and then and then end up removing it, we will end up possibly breaking people's existing code. I mean, I think we just have to make a decision of if we add it, we have to end up keeping it.
Yeah, I think that's I was like wondering in my head, why don't we just say, yeah, everything's const? But that's the one consideration is that like once we make it a const, we can't go back. So for a method, we want to be confident that, if we make it const, we don't think we ever need to actually modify internal state, right? Like if we look at these concrete examples, like object reference get, that I don't think we should be like that one off the top of my head is I don't think we really should ever be changing anything to do that, right?
Yeah.
Similarly for like ref, unref.
Well, actually, both ref and unref.
Actually, yeah. Sorry, right.
Because right now the only reason these can be const is because the actual referencing of things doesn't happen in the wrapper; it happens in core. Right. So we have the pointer, and we've established that passing a pointer from a const function to a non-const works because we're not modifying the object, we're modifying the object behind the pointer, and so that's fine. But I mean, if we ever change the implementation to handle the ref counting ourselves, and that's a big if, because the idea is that core handles this, because it has to be done on the V8 side. Then we would have a problem because we wouldn't be able to ref and unref if we stored the ref counter inside the class. So
exactly.
Yeah, there's a chance of that, but I mean, I think it also matters what we're trying to express with these semantics, right? And that's, the semantics reinforce the fact that we are a wrapper, not a provider of value, right? And I think in that sense, if we were to design these APIs today, knowing that these should be const. Would we mark them as const? I suspect yes, right? Because you want as many things to be const as possible, unless you are really, really changing state.
Right. Like this, a whole bunch of these, like, you know, even the, you know, you could look at the set and say, well, this is a wrapper around another object. So we should never really need to be able to change the internal state to do that, right?
Exactly. We should, ideally, we wouldn't have any internal state, right?
Right.
And I don't think we do, right? Because ideally, the internal state, quote unquote, melts away and just resolves into a bunch of like node API calls, right? And so
Right.
our internal state isn't any real state in the sense of there being data in the final executable that refers to our state. It should all optimize out.
That is a good argument as well for why having more const than less, it fits in with the model.
Yeah, and it forces us to it forces us to think twice before we add our own state, because we do add our own state for things like callbacks. You can't avoid it. To translate one signature into another, you have to add state.
Right.
Right. But this sort of intentionally and well-intentionedly binds our hands.
Right.
To not add our own state, if at all avoidable.
So maybe just as an exercise, let's go through all the ones here and see if there's any that we would say, let's not make const because of concerns of future need. Does that make sense?
Sure.
So getting clear pending exception.
That's a straight call through. So
yeah, run script. We should be running
equally. Yeah,
get instance data, set instance data. Those both go like into the DM, like the
yep,
DM.
These are one-to-one.
Yeah.
Yeah, these are one-to-one with core. Same.
Object setting and deleting.
Same.
Add finalizer.
And just to clarify, we're looking for concerns of our methods that would modify the C++ object.
Is that right? That's right. Yeah, okay.
Yeah.
And I think it is also worthwhile to point out that Gabe said that he looked at the PR and all of the tests passed. So that must mean that everything still compiles as long as all of those methods are tested. I would assume then that it should be safe to add, because
I think what we're trying to figure out here is all the methods here that this PR proposes to add const to, are there among them any that for which we at some point in the future would want to remove the const, thereby breaking them, right? And so far, like, we're still going down the list, but so far it looks like all of them are just straight pass-throughs to core, and therefore they can safely stay const. I think Deepak's waiting in the wings.
Yeah, I just was promoting him. Thanks right now. Yeah, that's exactly it. We, you know, sort of as a test case, let's see, are there any of these that we look at and say, maybe sometime in the future we would want to have some internal state. And that'll give us two things. If we get through the whole list and say, no, we can improve this. And also it tells us how likely it is that there'll be methods that we think we'd want to actually have some internal state and make sense.
Yeah, I was a bit concerned about the add finalizer, because like we may want to handle our own finalization, but then I realized that there's no way we can do that. Well, actually, there is a way we can do that, but that would be a different object, right? Because right now, add finalizer is another callback, right? So we do have our own state for that, because the pointer that the user passes to us with the data is not the same pointer that we pass to core. We wrap it up in an object, but then that object is non-const. Right. It's a pointer. So again, we're okay because we're not modifying the state of I don't even know what, is there even state here? Like,
well, there's state, but it's in, like, I think it comes back to your earlier comment that like we want these wrappers to basically evaporate.
Yeah. But what I'm saying is, oh, wait a second. Oh, this is, yes, exactly. Yes, you're right.
So even when we have state, like this add finalizer, we are changing some state, but we change it in the C API.
Exactly.
Because
yeah.
we want all of the C++ code to just disappear. So, and I think that'll typically be the case. Like if there is something that requires state, we probably want to add it to the C APIs so that the wrappers remain just, sugar.
Yeah, the state that we create in this method in add finalizer is not state that is stored in an instance variable of the object instance. It is stored in core.
Right.
And so we are not writing state, and nor are we ever likely to be writing state, because an API object, let's remember, is not a persistent, right? It's a local reference, and so storing state on it is completely useless because it dies as soon as it goes out of scope. So the only one where we should be careful is where we have like a reference. Like we have this template class called reference, right? And then that class is a candidate for having state.
Right.
And I don't know if any of these functions touch that, so it'll be interesting to see as we go.
Yeah, so we'll keep on going through here. Like has own property, define properties, operators. All of these operators, I think, just go back to
get and set.
Yeah, operators. I'm now wondering why these are deleted.
That's a good point.
Maybe there's a rebase or something needed here.
Oh yeah, that's possible.
So here we have get, ref and unref are even like back into that same state of like, but we're maintaining that state back in
core, yeah.
And it really has to be, because you could go back and look at that same value through the C API, right? So
yep, that's right.
Thread safe function.
Yeah, I think this is okay because these are all called straight through to core.
Right.
I think there's actually a workaround. I just realized there may be a workaround later on, even if we wanted to remove const on any of these, which is to just store the state that we need to modify as a pointer inside the object, just as the NAPI value is a pointer inside this object, which we can then modify, right? So let's say later on we want to have state that is modifiable inside, let's say, an NAPI value, right? So what do?
Right.
We make a member variable of NAPI value that is NAPI this new class star variable, right? And then inside one of our const methods we say this new class arrow method, which sets the state inside this new class, and we're good.
Yeah.
Just as we call into the core methods now, which modify what is behind the NAPI value pointer, so too can we call into our own methods, which modify whatever is behind the pointer to whatever new state we wish. So we can get around this constness as long as the state is stored separately.
Yeah, we would have to add some methods, like we would have to add something to the C API to manage that state. Which is what we do for the existing state, right? So yeah.
We could actually be cheeky about this. I'm just thinking, like, if we added, let's say we added the instances of this new class as member variables, not as pointers, as member variables on, let's say, an API value, right? And then we also added a pointer, which is basically ampersand the member variable. I wonder if we could break that, right? Because the compiler might not be able to follow that. We're dereferencing a pointer into our own state, which we should not be doing. That might actually be unsafe. So never mind.
But I think what we've proven is that, yeah, like the downside to that would be more object allocation and stuff, right? But the example has proven that that's perfectly legal as per the const semantics.
Yeah.
Right. So yeah, you're right. We could work around. It might cause some performance issues or whatever, but like looking at these still, like get instance data, set instance data. There was a little bit of discussion here. Set instance data, but again, it's in the background, right? So
yeah.
right? So these operators again. Delete. Just stop me if there's one that somebody sees that like. So you're talking about a little bit more worried about object reference, like references, because now we're in references, but
Yeah. Oh, but this is not these. None of these methods are. Well, and I think with our workaround, my concerns are alleviated, I think.
okay. So, and these should just be a repeat of what we just had here.
Yep.
So I think, yeah, let's just double check. I think it does need a rebase probably. Right.
Yep.
So I think having gone through that and with the having worked through the understanding, like I think I'm good with this landing.
Yeah.
What does everybody else think?
My only thought, like that this change is relatively old. We need to ask author to rebase it on the latest code and see if additional methods needs to be also modified.
I think we might think we can separately think about like, are there other ones that should be added, right? But we can, yeah. So it's like, I think, especially for the original author, I'd be hesitant to say before we'll land it, make sure you've covered everything else because it's been so long. I think we can ask for a rebase, and if they can also update things, they're great. But if they just rebase it, it might be good to land it, and then we could look for what's missing. If that makes sense to people.
It's okay, but at least I know that authors cares about this change because
that's
he contacted me a few weeks ago, and we start discussing this topic. So okay. I bet he can go back and do this, whatever is required. As long as we're okay with this change, he probably will be able to contribute to finish it up correctly.
Okay. Thanks for being so patient. Does that look like a good question?
Yep.
And everybody's comfortable with us say, yeah, basically saying, yeah, we're going to land this. Just, you know, you can rebase. And if there's a few other ones that need to be added, go for it.
Maybe add, we can land it afterwards.
Right.
Like at the end of your message.
Quickly-ish?
Yeah. Well.
Yeah. Soonish.
Soon. How about soon after?
Yeah, that works. Yeah.
Will be a major changes or minor?
Minor.
I think it's Semper minor. Yeah, like it is enabling new things, so like you can't go back.
Okay.
But yeah, it shouldn't. We don't believe it's going to break anybody.
Yeah.
Should I push the button?
Yeah.
Yep.
And Vladimir, like, thanks a lot for your help on working us through this and helping us improve our C++ understanding a bit anyway.
Yep, thanks.
Okay, so let's look at the next one.
I think that, yeah, he answered.
Okay. Okay.
Yeah.
Okay, so good. So basically we've given some feedback and we're now just going to wait for the author to do that.
I'm sorry, like I have can I say like a few words about this change that Sorry, I missed this meeting that you guys discussed this stuff. I just want to say like the stud vector always requires to have a copy. Like it does not behave as a span. I think it was some misconception during the last meeting then it was discussed. So even vector receives like a pointers stuff, but it does not behave like a span just pointing to your storage, but instead it's always copies from this source. And stud vector internally always does heap allocation. So technically it's not as efficient as might be.
Oh, wow, really? So even if you give it a pointer, it still copies?
Yes,
wow.
Yes.
Oh my goodness.
It does not behave like a...
Go ahead.
It does not behave like a span. Span is never does any allocation stuff. You effectively given its pointer and size, and effectively just keeps them internally. So it's just a view to the data. Whereas vector always have its own storage, always.
So basically with the pointers, you're telling it copy from here to here kind of thing.
Yes. So you're just providing source where to copy from.
That kind of makes sense because the vector you could then push new things into and so forth, right?
Yeah, that's right.
I mean, I think that would be an argument, not necessarily in this PR, but like that might be an argument to say we could add span versions of all of the ones that take vectors, right?
Yeah, but span is, what is it, C++ 20, I think? I think we're not there yet in terms of flags. I mean, we could talk about updating our flags to C++ 20 for Node add-on API because we don't need to track Node, right?
Could be too destructive to many people because convert to C++ 20 is a big step. And I know like many repos still even using C++ 14. My proposal would be like if we introduce span and to have like ifdef, if people using C++ 20, that span here would be really just alias for stud span. And but otherwise we provide just minimum functionality out of the spec. So technically it will be literally for developers as they're using new compiler and they see nothing changed to their code. It will be just magic.
Yeah, that's a good idea using an ifdef. Yeah, and we could use like a using thing to say like using an API span equals std span if available, otherwise not. Right, and then we could reproduce only as much of the span API as we need for our own purposes. We don't need the whole API. Yeah, I think that's a good idea.
And technically, modern C++ offers a bunch of special kind of definitions to test different features. Like I think it should be specific definitions, say like if library defines stud span. So technically, we don't even need to invent this definition to check. So we say we don't need to check if it's C++ 20, like because somebody can implement C++ 20, but don't have stud span. So we can do a specific check, like if library, what you use today, implements stud span. And
and that can be done like statically, like at compile time, this check?
Yes, ifdef, yes. What I'm saying, like what to test under ifdef. Under ifdef, there's special variable we can test for. If it's defined, then library says, I do have stud span. So we can just do using and do alias, like you said.
And when you say library, that's the
standard
the includes you're using, not the libc or any of those libc++s.
Well, hold on a minute. Is span, if available, is that like a number include span?
Yes, but same technically this define it's kind of defined, if you like, on global kind of scope. So if, for example, if it's defined, then we say include span and.
Oh, I see. Right. Okay, so the compiler itself provides the variable, the preprocessor directive. Okay, so then hash ifdef preprocessor directive, then hash include span. Otherwise, class or template blah 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 class span blah 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 endif hash endif. Okay, yeah, okay, yeah, that works.
I can actually look up what exactly needs to be done there, and if you like, I can also provide maybe some code snippet. I can play with the next few days and augment this PR with stuff. If we want to proceed with span.
I'm almost though like maybe we should just let him get this landed the way it is.
Okay.
And then because my recommendation is we don't add it just for this one method, right? Like if that makes sense for everywhere we've used a vector, we should probably do that everywhere in one PR that says, okay, well, we want to support span instead of vector. Here's doing it across the APIs.
I see.
Does that make sense? Like,
yeah.
I just have a thought there. Our methods we can add an override, and correct me if I'm wrong, for those methods that accept a const vector reference, right? Because a const vector reference you cannot change, or can you? I'm not 100% sure. Right? Like if one of our APIs takes a const vector reference, could you possibly add elements to that by the same mechanism as you could to like a const?
No, like inside of this method, this vector can't be changed because it's const reference.
Okay, good. So then for all those methods where we accept a const reference to a vector, then we could add an override with a span, because
yes,
the vector is in effect a span at that point, because you cannot change it. It just happens that the memory inside the vector is allocated by the vector instead of by the user. So anywhere we take a const standard vector reference, we could take a span.
Yes, it will be just technically different override. And,
yeah.
The only thing like we need to kind of look at, say, if we provide in something like initialization list, and we need to look at we don't have any conflicts. Who would actually take it span or vector? But I guess we have override specifically for initialization list, so technically it should not be an issue.
Yes. I think we do. Yeah, and then the inference should be simple for the compiler then.
Okay, sounds good to me. Like we can add this span support later.
Yeah, I think it's a good idea, but just not something we need to do, say, just for this one method. And let's just get this one landed to add the one method, and yeah, if you want to submit PR to add that for all the ones where it makes sense, I think that's a good way to go.
Yeah, it will be probably my first PR. Glad if you guys can help me.
Yeah, sounds good.
Absolutely, yeah. Looking forward.
By the way, I have a quick question. So if I want to submit some issues, which pretty much more like not issues, but more like topics to discuss about some design around, especially C and API and stuff, what would be a good repo to submit these issues to?
I think core has like a discussions thing where it's not an issue, it's not a PR, it's just discussion. There's like I forget what they're called.
Yeah, you're talking about this new feature of GitHub, like discussions.
Yes. Yeah.
Okay.
Is that on Node add-on API or the core Node API?
Core. Yeah, core has discussions.
No, but I mean your question, Vladimir, is on core, the core C API?
Yeah, core C, yes.
Yeah. Then opening either an issue or, I mean, I think sometimes the discussion happens in issues, but like, yeah, we've started using these discussions as well. So that's just another way of opening it.
Okay. There are a couple of topics I want to kind of discuss, but I want to write them down first. It's first of all about this versioning, and second is about all these references. So.
Sounds good. Because yeah, it's always good to have those written in the recording, like the discussion recorded. So when we forget what we discussed, we can go back and look at it, right?
Yeah, okay. and references are quite a topic. I think Michael and I we've tweaked that reference code like 59 times over the years.
Yeah, and just getting it so that it's like, I haven't looked lately, but getting it so that our tests pass reliably. There was some good fun that was generally related to the references.
Yep.
I found the issues implementing them on other platforms for other JavaScript engines, and I also start to hate them. So it's like I think like we can change something there. Sorry.
Sure, that would be good to have that discussion.
Looking forward to that. Yeah.
Okay, this one I think we discussed last time, right? Zheng had sort of tracked it down to the exact thing that we might backport and asked about where we would backport. I don't know if there's anything more on that one that you want to discuss.
I didn't have a chance to backport it in the last week, so probably I can find a next time to submit the backport PR.
Sounds good. And I think that's the end of the list we have here, so that's good.
There was another issue that the bot marked as stale.
Okay.
This was, and then we removed it. I guess you removed it last week. It's on Node add-on API. It's the pull request.
Right.
The last one in this list. And this was a migration of the older thread safe function to typed thread safe function. You can see that the name is also old. And the reason that we had blocked this was because it required a newer version of GCC than was required for Node 10. And since Node 10 is no longer in life, this could be put back onto the table.
Yeah, I think so it still made sense in my mind, right? That we don't consider it stale, and unless you think there's something has changed and we wouldn't want to do it now, but
I think it would be okay to work on. So this just means it's just a rebase and then making sure all of the tests continue to pass. Does that sound good?
Yep, sounds good to me.
Okay.
Yep.
So I can take that up and rework this then.
Right, so it goes to 4.9. So yes, that should, okay, that's good.
The problem was only on GCC compiler, or
yes.
maybe we should test maybe on Windows.
If our test matrix runs on all minimum versions required of the compilers, I think it would be fine, but I think, yeah, that's a good point. I can take a look into that to see what the build requirements for Node say, and then what's listed with our test scopes.
Yeah,
We have Windows here.
Yeah.
We do have them here, but yeah, it would be good to cross-check against like what we say is for add-ons, because sometimes there is a different minimum for add-ons versus Node itself. And Windows might be the one where we would, yeah. Not sure we have the full matrix here. So, but yeah, it would be worth cross-checking that. And then, we can run this on the PR before we land it too.
So if we were to land this change, would this force folks upwards, perhaps, if they use lower minimum versions than Node.js itself?
Oh, I believe that would be the case. Yes, like if they're using, if their code base is meant to compile for Node 10 using an old version of GCC, and then they decide to upgrade Node add-on API to get some other new feature or something, then yes, that would break.
I think we would have to call this one Semver Major.
Mm-hmm.
Yeah.
And in fact, it might be good to get it in, like, because I think we're going to plan a Semver Major for dropping 12.
Yeah.
So maybe it's good to kind of align it with that. Like, when we do the Semver Major to drop 12, this also goes in, and that would be that, like, you'd have to be using 2 old ones, like not just the past LTS, but the LTS before that to run into 12.
Okay, that makes sense.
And that seems fair enough. Like if we don't cut things off at some point, we'll be,
Yeah.
Right. Okay. I like that idea. That's all that I wanted to discuss for stale then.
Okay, that sounds good. So back to milestone 11. So tracking for modules reported. I guess nothing really new there. I think in terms of, let's just see, npm, 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 I think was just still no massive changes or difference, but still a pretty healthy weekly download. So then looking drives for full coverage. I guess we don't have Jack out. I don't know if anybody else has any comments on that one. No, okay. So enabling debug testing for add-ons, dpack.
Hey, Michael. Yeah, I scratched the comment only today morning. You can take a look at it.
Okay.
I also fixed comments from Gabriel only today morning. So
okay.
Maybe we can take a time until next meeting.
Sure. Well, I'll try. You know, I think the Gabriel's comments were pretty minor now. So like, I think if they, you know, if it looks like they're addressed, I'd prefer to go ahead and land it. So
okay, cool.
I'll give that a shot. Hope maybe this afternoon, depending on if other things get in the way or not.
Okay.
Okay, that's great. And then we're down to the list of issues. So I don't know if there's any issues in either repo that people have in mind that we should talk about.
I would like to talk about the signal issue.
Right, which one is that?
Should have this number memorized. I've looked at it.
It's burnt into your memory.
There is an open PR for 1086.
There we go. Okay.
So what this was doing is removing const from those methods, and then he added tests to make sure that they work, and then the tests don't work because signal wasn't being called. So I've looked into this, and what we had talked about last time was sort of modifying what we like package up and use in our internal code. So, you know, either they give us directly their data they want to send, and then we flag that as, okay, this is data, send it. Or when they call signal, we wrap it and say, oh, this is a signal call instead. And I don't have any code pushed, but I was able to fix it in a way. If we want to open up the NAPI inline file, and I can give you, I guess in main is fine, actually. Sure. And I can point you to the line number that I've been sort of working on. Line 5805.
Oops. Here we go, right around here.
5805, 5,800.
Ah, okay, that's massively different. I was thinking that didn't look right. 5805.
Yes.
There we go. Okay.
So we already have this sort of wrapper object of this thread safe data that we see here, which points to the async worker itself and the data that is there. So what I did was I modified that structure to have a true false Boolean in there to say whether it's signal or not. And that it works, but I'm seeing the same issue where if you call the method multiple times, sometimes it doesn't get called. And I think that was similar to the other issue that actually made this fail, which was calling it with null pointer or something. And I'm not sure the internal workings of all of the libuv threading and whatnot as to why, if we do several non-blocking calls, stuff just doesn't get called or something like that.
I have a hypothesis. Maybe the core implementation of an API thread safe function has a bug in it. Like I wrote that, and I've tested it as best I could, but maybe I missed a spot. And because the idea is, the semantics are that every call from the thread results in a call on the main thread, right? Whereas the semantics of just a simple UV async handle are such that any number of calls from the secondary thread result in at least one call on the main thread, right? So basically the raison d'etre for the thread safe function is to go from this many to one semantics to a one-to-one semantics, right? And I did my best to do that, but I may have missed some synchronization issues or something. So one possible way forward that I can think of is if you could try to write all of this without using node.js API. So just, you know, like you have the context for how the calls are happening in sequence right now, right? And what the expected outcome being that every single call actually appears on the main thread, and the actual outcome being that some of them do not, right? So if you can reproduce this with C alone, then you will have uncovered the bug in thread safe function, right? Because then we can eliminate node.js API as the culprit, right?
Okay.
So that's another possible avenue forward. And if you don't, then that's also valuable information, because then you know for sure that it's somewhere node.js API, right?
Right. Okay. I like that.
So,
okay.
Yeah.
Yeah. The other thing too is like having to remove the const. What is the internal state that we're changing? That const.
Oh, you have
That's
const
just
cast?
So the original, it was a discussion. If you go back to the pull request 1086.
This one, right? Yeah.
Yeah. He discusses that there, because we had all asked, like, is it possible to remove or put const somewhere else? And then this was his chain of reasoning here.
Right. It goes down to call something on progress needs const. Right. This is a case where like adding const to method to our methods, if we don't think they're ever going to be const, isn't a breaking change. But if we add const, like if we have to add const to a method we ask the end users to implement, that is a breaking change.
Correct.
Okay, so this is a little different than the other one. All the other ones we looked at on our wrappers, which we just do our own thing. This is one where like we're saying like, hey, you have to implement this.
Right.
And it's because our chain ends up, you know, we call their method from a chain which we've marked const, which really isn't, we haven't forced that to be const on the end users, which is a potentially breaking change. Yeah, okay.
Right.
So that's another sort of wrinkle to think about when we think about other methods, but I don't think that applies to any of the other ones we saw. So
I agree.
Okay.
Okay, I think I have enough info to move forward with this then.
Can I just kind of comment on this kind of writing here? It says like conditional variable member variable where notify one is non-const. It's typical that many kind of classes which using some synchronization primitives like conditional variable, mutex and stuff, even method is const, but typically this member variables marked as mutable, because technically it's considered to be acceptable that kind of synchronization primitives inside of classes mark as mutable. Like for example, ref counting is in com in typically it's mutable field.
So just for clarification, would that mean that you would be able to make the method const, but then you signify precisely which variables are changing by marking them mutable?
Yes, yes.
I see. Hmm.
The challenge here is like, we'd still be breaking existing code. It's the,
Yeah, sorry, I don't have scope stuff. I just want to comment on this
yeah,
last
no, that's good.
bullet point. It's,
Yeah, I
Yeah.
think it's good to bring that up because it's C++ knowledge that you're sharing with the group, which I greatly appreciate.
Yeah.
Thank you.
Okay, so you've got the next action on that one.
Yep.
Let's just look at our pull requests. Any of these ones we think we should talk about today? Am I in the right? No, yeah, I'm in the right one. I don't see anything too new. So, know what this is. Okay, I guess this one we're just waiting to see if they can fix up the linter errors. Nothing to talk about there. Let's take a quick look in the node repo itself. And actually, no, node API. There we go. This one's, I know, Vladimir, you opened.
It's not me, sorry.
Oh, sorry, no, it isn't. Right, yeah, no, okay, that's what I confused. That's what I was asking you about another issue. I've confused myself with people, but yeah, okay.
My alias Vimaros.
Right, yeah, no, sorry, just.
So, okay, is this asking to transport exceptions out? Okay, what's this? Throw a JS exception on an async callback call to thread safe function. Oh, wait a minute. So your own async callback? Throw a JIT from an async callback.
Is this?
Okay, yeah, this so if you throw an exception from there, yeah, this may be worth a test in core, like for core thread safe function. Yeah, I don't know if there is anything special that we can do, right? Like if the user's JavaScript thread side callback, which processes the incoming async message from the secondary thread, if that throws an exception, then we are, you know, we're in an async context, and I'm assuming the async context should correctly throw the exception at some point, but I don't know that we can do anything special there to ensure that that happens.
I think you're right about a test would be useful though, to say like,
yeah,
what is the test would help us validate, like in this situation, does what we think should happen, right? Like,
yeah, let me see what we have in core right now.
Or if we somehow swallowed it, or, you know, maybe we're missing a check pending exception or something, right? Like when we come back from their call.
Well, but it's async though, right? So it goes back into it goes straight back into the UV event loop, right? It doesn't go through the engine anymore. But that's what async context is supposed to handle, right?
Right, like it's, I guess in any async context, you should get, if you throw an exception, something should happen, right? Like maybe it's like they said, node just exits or.
Yep.
Somebody's phone is going off.
Oh, sorry. Yeah, that's mine.
Okay.
Okay, so let's see. Git pull origin master. Okay. Okay, so test.
And just from my understanding, this is an issue when the call JS function has an exception.
So the callback function which you give during the construction of the thread safe function, which is responsible for turning whatever data is coming from the secondary thread into like an API values or
Right.
whatever JavaScript can digest. If that call or if that function throws an exception, apparently that exception is getting swallowed rather than bubbled up to wherever it's appropriate. So that's the problem.
Yeah, and it should have the same behavior. Like if I did a set timeout, and in that code for the timeout, I throw an exception.
But I'm not even sure like how you would handle that exception. Like, are we talking about a C++ exception or a JavaScript exception?
No, a JavaScript exception.
Okay.
So I think the way you would handle that is you would have like an unhandled exception handler attached to the node process itself. So like we have like this unhandled exception event.
And if you don't do that, that node crashes effectively.
Yeah, that's which is the desired behavior in this case.
Right. So that you know you're getting exceptions you're doing nothing with.
I just recall a PR that I previously submitted. I posted the link in the chat. That is this PR just catches the uncaught exception and emit it through what we are doing with JavaScript uncaught exception now. But it may break currently running programs, since it may crash the program, so it's marked as server major. And we don't have progress on this since we lack for reviews on it, so probably we can pick this up.
Yeah, I was just hoping, Gabriel, if you had a chance to look at it as well, because it is.
For what it's worth, the word throw does not appear in the thread safe function test in Node core. So I don't think we're throwing anything.
So it may be like here. Do you have a test in here? Throw. Test finalized. No, this is all around finalizers. But it could be a similar.
Yeah, this is we have to shepherd the exception through the stack and make sure that it gets bubbled. And find out where it's getting swallowed and why.
So I think we figured this one would be like it could cause code to like it might actually cause some existing code not to run anymore, but I think in our discussion we still thought it was the right thing to do in this case.
Yeah, it is correct behavior to
and that it's low enough chance of affecting existing code. Like the existing code is already not doing what it was expecting to do.
Yeah.
And we're in an inconsistent state. So, I think it's still like Semper Major, yes. And okay, you might end up with some add-ons that worked okay in older versions, but not new versions. But like this is a case where that's a small enough chance and you really want to surface these. Like it's really a bug.
Mm-hmm. Yeah.
So we should do it. Is kind of what.
I guess I have another question just regarding how it function. If you have an exception, a JavaScript exception in that call.js handler, wouldn't then your environment have that state where it has a pending exception so that the next time you try to run any JavaScript, you would get a fatal error? So your program would crash?
Exactly. Why isn't that happening?
Why isn't that happening?
Yeah, like it may be that somewhere we clear that without noticing that it's there or something.
I see.
We're doing something, maybe we're doing something which hides that when it shouldn't.
Gotcha.
Right. And the other thing we did talk about on this PR is like we actually have a policy, like we have a flag so that if this turns out to affect more people than we think, there'll be a flag in that major for them to be able to turn it off. And if we got a whole bunch of reports that we've made a mistake, we might revisit, but at least we don't think it's going to affect, hopefully, users in a way that doesn't make sense. And two, we've got a fallback for them, and we really think it should be done, because ignoring that exception is pretty bad. So yeah, I was just hoping, to have another couple of, since it's got all that sort of going on, it would be good to have a couple more approvals before we landed it.
So I'm sorry, but I'm a bit confused that the PR is marked as a single major PR. Yeah. And from what I'm understanding, you just saying that we may land it in, like, say, version 14 or version 12?
No. I was just, I guess what I was saying is like, we really we just avoid Semver majors in Node API because it's meant to be stable across versions, right? So the fact that we've got a major version, even then we normally wouldn't make it. We'd add like a new method or we'd work around it. But like for this one, I think it is the right thing to say, well, we're going to land it in a Semver major. We're not necessarily going to backboard it, but like going forward, you'll get the right behavior. And we don't think that'll affect people. And if it really does affect people, we've got to fall back through the flag.
Yeah.
And then, over time, we're not backporting it. So the problem's there, but like over time, that'll become less and less of an issue.
Yeah, sounds good to me. So the PR just needs a rebase and the behavior don't need to be changed. Maybe more reviews.
Yeah. Maybe exactly. Remove I don't know, it might be worth removing the Semver major label because it is kind of a bug fix. So
but that's what prevents it from being backported. So I think we need to
I see. Okay, then yes.
Yeah. Like that's the signal that says no, this doesn't go back. So
okay, got it. Okay, sorry.
So yeah, I think just a rebase and then get another review or two would be good to land it because it's, especially as a Semver major. I think actually as a Semver major, we need at least 2 TSC reviews anyway. So.
Right.
Anything more on this one we should talk about? No. Okay. Any others that we should? Actually, I see we're over time as well. So, any others that we should talk about before we close out? If not, I think we should close out at that point. And so, thanks for everybody's time, and we'll see everybody in GitHub and then next week.
Yep.
Thank you so much.
Bye.
Thank you.
Have a good weekend.
Bye.
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 Bye.